Hello everyone, welcome to WAPSI. Myself Ashwandas and I am going to be your new chemistry tutor. Today we are going to discuss about previous year questions on KCET. Right now, shall we move on to first question. The first question is, among the following the main reactions occurring in blast furnace during the extraction of iron from hematite are. So, as we all know that hematite is ferric oxide, which means Fe2O3. Here, this is hematite. We extract iron from this hematite ore by heating with carbon or coke. So, for the first reaction, we should actually burn coke in excess oxygen to form carbon dioxide. This carbon dioxide is again reduced to carbon monoxide. This carbon monoxide is used to reduce the ferric oxide to iron. That is the reaction we are going to discuss here. See, here Fe2O3, on treating with carbon monoxide, we get Fe along with CO2 and other products. Okay, and the additional reaction we use in this blast furnace is the calcium carbonate, which is also known as limestone. This is actually heated to form calcium oxide along with the carbon dioxide. Okay. This calcium oxide is then treated with the excess slug or the impurities in the blast furnace to form a molten state, which is the slug which is used here is silicon dioxide, which can be formed by CaSiO3. This molten state is separated from the blast furnace and the pure iron is extracted. So, the question is, which are the main reactions in this options? So, here we have discussed on extraction of iron from iron oxide. So, we can tick at the first option, and removal of the slug or flux from the blast furnace using calcium oxide. So, it is option 4. According to that, we have sorted out two reactions from this, and the correct option would be 1 and 4, which is option number 4. Okay, we will move on to the next question. So, moving on to the second question, which of the following pair contains two lone pair of electrons on the central atom? So, we can rule out the possibilities of ammonia and NF3. We all do know that ammonia contains only one lone pair of electrons. So, we could rule out the option 3 and 2. So, on our hand, we do have I3 plus and water and SO4 2 minus and H2S. Here, looking at the H2S structure, it does have two lone pair of electrons similar to that of H2O. Okay, and in the case of SO4 2 minus, it has only one lone pair of electrons on the sulfur atom and total 12 pair of lone pair electrons in total. So, we could rule out the option of 4, and we do have I3 plus and H2O. I3 plus is a linear molecule having two lone pairs on the central iodine atom and 3 pair of lone pair electrons on the end iodine atoms. The structure of I3 plus is like this one. As you could see, it only contains two pair of lone electrons on the central metal atom. So, the option for the question 2 is 1, I3 plus and water. Let us move on to the next question. Which of the following statement is correct? Chlorine oxidizes water to oxygen, but fluorine does not. Here, chlorine oxidizes water to hypochlorous acid and hydrochloric acid, does not oxidizes to oxygen. So, the option 1 is wrong. Let me explain the first reaction here. Chlorine, when treated with water, it converts to HOCl, which is HClO, which is hypochlorous acid, okay, and HCl. So the option 1 is wrong, and the second option is Cl2 is a stronger oxidizing agent than fluorine. That is also wrong, because fluorine is the most strongest oxidizing agent in the periodic table due to its negative reduction potential of fluorine. So option 2 is wrong. Fluorine oxidizes water to oxygen, but chlorine does not. Here fluorine does oxidizes water to oxygen. So option 3 is right. But we could look at the option number 4. It says here fluoride is also a good oxidizing agent, fluoride, which is F minus, not fluorine. So option 4 is also incorrect. The correct option for the question number 3 is 3. Fluorine oxidizes H2O to O2, but chlorine does not. And the question number 4, 0.1 mole of XeF6 xenon fluoride is treated with 1.8 gram of water. The product obtained is, here you would be wondering why they gave the molarity of each XeF6 and water. This is due to the fact that they are explaining the molar ratio of both the reactants, XeF6 and water. Here there is 0.1 mole of XeF6 xenon fluoride and 1.8 gram of water. What is the molarity of what is the number of moles in water? It's given by given mass by molecular mass. Here given mass is 1.8 divided by 18 molecular mass of water, which is 0.1. We do know that the ratio between the reactants are 1:1, isn't it? So the product would be XeOF4. Okay. We have studied along the xenon fluoride reactions that if the reactants are in the 1:1 ratio, the product would be xenon oxyfluoride, XeOF4. Okay, so the correct option for the fourth question is option 3. Moving on to the next question. In the reaction of gold with aqua regia, oxidation state of nitrogen changes from. See, before moving on to the question, let me explain the reaction of gold with aqua regia. As you know, aqua regia is a mixture of both hydrochloric acid and HNO3 in the ratio of 1:3. Here, let me explain the anionic reactions. Gold along with 3HNO3, see, and 4HCl. This is aqua regia, which gives an tetrachloroaurate, AuCl4 minus. This is the anion that formed from the reaction of gold in aqua regia. Along with we get a nitrous oxide, nitrogen dioxide and water. Okay. Here the oxidation state of nitrogen in HNO3 is +5. Okay. You could calculate the oxidation state from the given compound and it changes from +5 to +2. It's given in the nitrogen dioxide. So the correct options would be option number 3. Okay. Question number 6. The vitamin that helps in the clotting of blood is the options vitamin A, C, B2 and K. We have studied in the biomolecules chapter that the vitamin that helps in the clotting of blood is vitamin K. Vitamin A helps in the night blindness, C cures scurvy and B2 helps in the bone strengthening. So the correct option would be option number 4. It's an easy question. Let's move on to the next question. The polymer containing 5 methylene groups in its repeating unit. We have studied the chapter of polymers here. So the correct options would be nylon 6. You know, the molecular formula of nylon 6 is which contain repeating CH2 units, 5 repeating CH2 units and a carbonyl group. This is nylon 6. You will be wondering what is nylon 6,6. It's actually a long chain carbon of adipic acid and sodium stearate. So, nylon 6 is the correct option for repeating 5 methylene groups. And question number 8, cis 1,4 polyisoprene is also called. Well, before answering that, let me first draw the structure of cis 1,4 polyisoprene. Here polyisoprene would be C double bond C, cis, which means 1 CH3 here, CH2 here. This is the structure of cis 1,4 polyisoprene. This is also known as natural rubber. Here the correct option is 4. Moving on to the next question. Which cleansing agent gets precipitated in hard water? You all do know that soaps contain sodium stearic acid. So, the correct option would be sodium stearate. This is a correct option for question number 9. Such an easy question, we could move on to the next one. Antihistamine among the following is bromophenramine, morphine, amoxicillin, chloroxylenol. What do you think the most antihistaminic drug in these 4 options? We could cancel out the chloroxylenol, which is an antiseptic, commonly called a Dettol, that is chloroxylenol. So, we could rule out the option 4. And we could also rule out the option 2, morphine, which is an narcotic drug used for the patients on last stage of cancers and all. So, we could rule out the morphine. Amoxicillin, what is amoxicillin? It is an antibiotic. We could also rule out amoxicillin. So, the correct option is bromophenramine, which is an antihistamine drug for the common cold and all, which is an allergic reagent. Moving on to the next question. The mass of silver chloride precipitated when a solution containing 11.7 gram of sodium chloride is added to a solution containing 3.4 gram of silver nitrate. This is the question we have, and we could explain this by a simple precipitation reaction between sodium chloride and silver nitrate. Let me do that first. Okay, here we have silver nitrate when treated with sodium chloride. See, the most precipitated would be silver chloride along with the sodium nitrate. You don't have any doubt in this reaction, right? It's an easy precipitation reaction. Here we write out the known data. Here we do know that the data for silver, moles of AgNO3 gives like given mass by molecular mass, which is 3.4 by 130, which is 0.02. Okay, and silver chloride gives 0.02, isn't it? Yes, 0.02 moles of silver chloride along with 143.5, which is 2.87. Okay, do we have the option 2.87? Yes, it is option 3. Okay, moving on to the next question. Two particles A and B are in motion. If the wavelength associated with A is 33.33 nanometer, the wavelength associated with B, whose momentum is 1/3 of A, we have to find the wavelength associated with B. So, we could write the known things we have. We know that wavelength of A is 33.33 nanometer. Okay. we could convert that into meter because all the options here are in meter. So we could write it as 33.33 into 10 raised to 9. This is because 1 nanometer is equal to 10 raised to minus 9 meter. Okay. We have converted the wavelength of A, and the next known thing is that momentum of B is 1/3 of momentum of A. Okay. This is what we know. According to de Broglie's law, we do know that wavelength associated is given associated of a particle is inversely proportional to the momentum. We have Planck's constant with that and P. Okay, this is de Broglie's wavelength, and we could write that wavelength of A is equal to h by P of A, and wavelength of B is equal to h by PB. Okay. On dividing of reaction equation 1 and 2, we get that lambda A by lambda B is equal to 1/3, isn't it? We could cancel out both h and momentum of A particle and B particle by giving PA is equal to 1/3 PB. So we could get the final result by lambda A is equal to lambda B into 3, and with this we could write lambda B is equal to 33.33 into 3, okay, into 10 raised to 9. This is foremost what we got here, which will be 99.99 into 10 raised to 9, which is approximately equal to how much? 1.08 into 10 raised to minus 7. Isn't that? Yes, 1.0 into 10 raised to minus 7, which is option number 4. Okay. Have you understood that? So the next question is, the first ionization enthalpy of the following elements are in the order. We do know that the ionization enthalpy increases from left to right in a periodic table and decreases from top to bottom. So here there are 4 elements: carbon, nitrogen, silicon and phosphorus. Here ionization enthalpy increases from carbon to nitrogen. So carbon will be the highest one. We could cancel out option 1 and option 3. Okay. It decreases from top to bottom. So we could say that option number 4. Okay. Have I done? Yes, option number 4 is the correct answer actually. Silicon is lesser than phosphorus, lesser than carbon, lesser than nitrogen. You know, ionization enthalpy increases from left to right in a periodic table and decreases down from a top to bottom in a periodic table. So option 4 is the correct one. Moving on to the next one. Solubility of silver chloride is least in. Here the concept that is associated with this question is common ion effect. Ions common both in the reactants and solution and solute helps in reducing the solubility of the reactants. So here common ions like chlorine in silver chloride and all these solutions might tender the solubility of silver chloride. So here every options have 0.1 molar of solution. Pure water we could exclude that because which is lesser than silver chloride, and here NaCl has 1 chlorine, BaCl2 has 2 Cl minus ion, and AlCl3 has 3 chlorine ions. So the product is so the correct option would be option number 4, because there are 3 chlorine ions in the solution, which hinders the precipitation of AgCl. So we could say that 0.1 molar of aluminum chloride is which gives the least solubility. Moving on to the next question. Which of the following equation does not represent Charles' law for a given mass of gas at a constant pressure? What do you mean by Charles' law? How could we explain Charles' law? Which is at a constant pressure, in a given gas has a volume which is directly proportional to the temperature. Like at constant pressure, V is directly proportional to T, and by saying this, V is equal to KT. Okay, we have given that V by T is also K. So option 1 is correct one. Okay, the question is which does not give the Charles' law. On giving logarithm, log V is equal to log K plus log T, isn't it? So option 2 is also correct. On differentiating with respect to time, we get d ln V by dt. Derivative of a constant is 0 plus d by dt of what? Ln t, which is 1 by t. So the option would be d ln V by dt is equal to 1 by t. Option 4 is also correct. The option that does not give the Charles' law is option 3, which is log k is equal to log V plus t, which is wrong. So option 3 is the correct one, correct option.